guys, we are going to move into chemical equations. Last lesson we learned about counting atoms and the difference between a compound and an element. Now we're going to take that a little bit further and tack on how to write and understand chemical equations. Okay? There's not too much writing in this one, it's just a lot of writing examples and practicing. Alright, so what is a chemical equation? A chemical equation expresses what is happening in a chemical reaction using symbols. Okay, so when we are making something, we can write it out in chemical equation form so that other scientists know what we used and what happened in that reaction. Okay, you can see the different parts of the equation. Okay, we have our reactants, they're always on the left side, so our reactants are what we start with. Okay, and our products are on the right side, and that is what we end with. Okay, alright, and then right here our arrow in science means yields or produces. So we can read this as two potassium molecules react with chlorine to yield or produce two potassium chloride molecules. Okay. Alright, law of conservation of mass. We've talked about this a lot in class, but you need to write it down, and we'll talk about it again. Okay, in a chemical reaction, matter cannot be created or destroyed. It can only be changed. Okay, we talked about many examples of this in class. When you lose weight, you're not destroying that fat. When you gain weight, you're not creating it. You're using other types of matter and changing it into that fat. Okay, same thing in a chemical equation, like when we did our baking soda and vinegar. We didn't add or we didn't create bubbles. What we did was take two substances, and when they reacted, they changed their matter into matter of the bubbles that we saw. We also created a new substance, which was a gas. We didn't create it out of thin air. We took two reactants, our baking soda and vinegar, and made a new product using the same amount of mass. And we massed it in class to show the law of conservation mass. So the reactants, what you wrote down earlier, the reactants on the left-hand side must always contain the same elements and the same number of each element as the product, but they can be in different compounds. So they can look different, they can be rearranged, but the same elements that are on the reactant side have to be in the product side, and the same amount of those atoms on the reactant side need to be in the product side. Okay, so here's an example. Okay, you will see we have two atoms of hydrogen. We know that because we have our subscript right here who tells us two atoms of hydrogen, and we have our two atoms of oxygen. So we went ahead right here and wrote out our reactants have two hydrogens and two oxygens. Well, in the law of conservation of mass, that means whatever we have over here has to equal this side. And as you can see over here, okay, we have two hydrogens, so that matches, but we only have one oxygen. So this equation does not follow the law of conservation of mass, therefore it cannot exist. Okay, so what we would have to do is go in and balance that equation. So we would have to go in and change things about our equation in order for us to get the same amount of atoms on each side. Okay, so right here is how we would change that. Okay, so when we are balancing equations or changing them, the only thing we can change is the subscript right here. The coefficient. We can never, ever, ever change the subscript. Okay, we cannot. So you see here that we've added a coefficient of 2, okay, to each side. So when we multiply that out, we now have 4 hydrogens. Now, here's the next thing. When they are separated, when two compounds are separated by a plus sign, they do not share. this coefficient. They do not share the coefficient. The only time that they share a coefficient is like right here, when they are all together and they are not separated by a plus sign. Okay, so we would have 4 hydrogens on this side, and we'd have 2 oxygens. So here we would multiply out, and we'd have 4 hydrogens and 2 oxygens. And so now our equation is balanced, and it follows the law of conservation of mass. Okay? Okay, so we don't really focus on being able to balance in the 8th grade. What we have to do, though, is be able to recognize if one is balanced or not. Okay? So as we go through, you need to look at these slides and decide are these examples if they are balanced or not. Okay, so let's look and see if these are balanced. Okay? So we would do is do like we've always done. We count our atoms on both sides. Okay, so we know we have a subscript here of 1, so we have 1 sodium, and we have 2 oxygens. So if we go over here, we have 2 sodiums and only 1 oxygen. So are we balanced? Do our sodiums match? No. Do our oxygens match? No. So we are not balanced. Okay, let's try the second one. Okay, so how many magnesiums? We only have 1. Okay, we multiply out. We have 2 hydrogens, 2 chlorines. So we've got a C on this side. And we have 1 magnesium. We have 2 hydrogens. 2 chlorines. And then we have 2 hydrogens. So our magnesiums match. Our chlorines match. And our hydrogens match. So this one is a yes. It is balanced. Okay, you should be pausing after you write down each example and work on your own so that you know how to do this on your own. Okay, here is our next practice. Okay, so let's see. On this side we have to count how many hydrogens. So we only have 1. We only have 1 oxygen. Oh, not hydrogen, excuse me. One element. Okay, we only have 1. And then we have 2 oxygens. Okay, so we match right here. Do we match right here? No. So this is not balanced. Right? Start with the second one. Okay, we have 2 nitrogens. We multiply out. We have 6 hydrogens. Multiply out here. We have 2 nitrogens. 6 hydrogens. So we match here. And we match here. So yes, it is balanced. It follows the law of conservation mass because the same amount we have here is the same amount we have over here. It does not look the same on either side, but it's for the same amount. And we'll do our last one. Okay, so our zinc, we have 1. We have 2 hydrogens, 2 chlorines. On this side, we have 1 zinc, 2 chlorines, 2 hydrogens. So our zincs match, our hydrogens match, and our chlorines do not match, or they do match, excuse me. So yes, this is balanced. Okay, we will be practicing this in class. If you have any questions, please come in for tutoring Friday morning, and we will be talking more about it on Friday.